Hi ladies and gentlemen, we're ready to start our second unit, which is linear versus exponential. We're going to talk about the difference between linear and exponential functions. So we're just going to kind of describe the differences between it in different contexts or different situations today. And then we're going to do a small task. That's about it today. So here we go. So if I have a sequence, how do I tell if a sequence is linear or if a sequence is exponential? Well, remember we just got done talking about sequences. So if it's an arithmetic sequence, if it's an arithmetic sequence, then it's linear. And if it is a geometric sequence, then it's exponential. So that's how I tell the difference there. So remember, an arithmetic sequence has a common difference, and a geometric sequence has a common ratio. And if you need to remember what the definitions of those are, if you go back to the last unit, there's a vocab list at the bottom of that unit that will help you with that. Just as a quick FYI on that for you. Now we're going to talk about what the equations look like. Again, they kind of go along with our arithmetic and geometric sequences. The equation for a linear looks like, you should recognize this, y equals mx plus b, where m is my common difference. And we also call that our slope. I know we haven't talked about slope yet, but some of you do know what slope is. I'm going to throw that word out at you now. We're going to start talking about that in a little bit. So I'm going to start throwing that out there, slope. And b is my 0th term, or my y-intercept. Since we're going to start talking about graphs pretty soon, we're going to throw out slope and y-intercept at you for that. So know that those terms are interchangeable. My common difference and my slope, my 0th term is also my y-intercept. Okay, and the equation for my exponential looks like this. Y equals a times b to the x power. Remember that x is an exponent, exponential, kind of words go together there. And then a here, what's our a stand for? A is our 0th term. Good. And b is my common ratio. Right, it's my common ratio. Okay, so that's what the equations look like. Our tables, what happens if I have a table and I'm looking at a table? I'm going to slide this up a little bit. So my table, if I look at my differences in my y's, first I want to look at my differences in my x's and make sure they're a difference of 1. So am I a difference of 1 there? Yeah. So now we're going to look at our y's. What's the difference between 1 and 3, 3 and 5, and 2 and 7? Well, what am I doing? Let's try and get the right pin here. What am I doing? I'm adding 2 every time. Great. So if I'm adding, if my difference and my common difference, that means I'm adding 2 means I have a common difference, which means I have an arithmetic sequence. And then also, if you look here in this particular table, it gives me my 0th term. Oops, I spelled term wrong. Term, and I have a common difference because I'm adding. Remember, I get a common difference if I add or subtract. And then in my next table, how do I get from 1 to 2 and 2 to 4 and 4 to 8? Well, from 1 to 2, I'm adding 1, but if I add 1 to 2, I don't get 4, so I'm not adding. So how else can I get from 1 to 2? If I'm not adding 1, I'm multiplying by 2. Well, 2 times 2 is 4, and 4 times 2 is 8. Yep, so I'm multiplying by 2. So that means this is a common ratio. Good, ratio. And I still have my 0th term. Okay, if I have a table that doesn't have a 0th term, I just go backwards 1 step, remember? So we're going to talk about that next time and how we do that. Or the time after, I'm not sure. Sorry. Can't remember which time we're going to do that on. And then a graph. Let's see what the difference between a linear and exponential graph is. And I'm just going to use the table, and I'm going to plot the points and draw in what the graph looks like. So my first point is 0, 1. And then I've got 1, 3, and 2, 5, and 3, 7. And if I can draw this line here. Ooh, that wasn't too bad. If it's linear, I have a straight line, right? There's no curves, there's no, other than my bad drawing, there's no curves or waves or anything. It's a straight line. Okay, and now let's go ahead and graph the other one. So I'm starting at 0, 1 again, and my next one is 1, 2, and then 2, 4, and then 3, 8. So that's 7. That right there's about 8. And I want to go back one. What happens if I go to -1? So, right, so it's half of 8 is 4, half of 4 is 2, half of 2 is 1. What's half of 1? 1/2. So what's happening every time is I'm just getting smaller by a half. Am I ever going to get to 0? No. But I'm going to get super close to 0. So this is kind of what it looks like. There we go. So I have a curve on one end. It looks like it's going straight, and then it curves up. So it's a I don't want to say modified curve, but only one side curves up. Let's just say one side curves up. Okay, and it curves up pretty fast. So that's what an exponential looks like. Okay, you guys, that is what we're gonna stop here on this video, and we're gonna do another one really quick where we're gonna kind of talk about the differences a little bit in a little task that I'm gonna work through part of it with you, and then you are going to do the last part on your own, and then we'll have a little bit of homework for you. Okay, guys, I'll talk to you in a few. Bye.